Hello everyone. Today we're going to learn how to divide two powers that have the same base. All right, so the do now for today is a little warm up just to refresh our memories of what we learned last week regarding powers and exponents. For question number 1 here we have 5 squared times 5 to the 4th. Remember, when we have the same base, all we have to do is add exponents. 2 plus 4 is 6, so our answer is 5 to the 6th power. Number two is a little bit different. We have 5 to the 2nd power raised to the 4th power. Remember that this means 5 to the 2nd times 5 to the 2nd times 5 to the 2nd times 5 to the 2nd. And the shortcut is simply to multiply the exponents, which gives us 5 to the 8th power. The last example here, 5x raised to the 3rd power, means that exponent applies to everything on the inside. We rewrite that as 5 to the 3rd, x to the 3rd. Okay, let's talk about how we can evaluate 5 to the 3rd divided by 5 to the 2nd. Okay, so if we were to rewrite this as a fraction or in fraction form, we would rewrite it as 5 to the 3rd divided by 5 to the 2nd power. We have 5 to the 3rd, which means 3 fives on top, 5 to the 2nd, which means 2 fives on the bottom. And what we can do is simplify a 5 on the top with a 5 on the bottom. We wind up being able to do this twice, and that leaves us with 5 to the 1st power. I want you to start thinking about if you notice a pattern here between the exponents in our example and the quotient that we get. Okay, so let's talk about this table here. Let's complete this table really quickly. 2 to the 4th divided by 2 to the 2nd. 4 2's on top. 2 on the bottom. We can simplify these two, and that gives us 2 to the 2nd. Again, keep in mind the relationship between the exponents. Next one here, we have -4 times -4 times -4 times -4 times -4 over -4 times -4. We can simplify that. We get -4 to the 3rd power. Again, notice a relationship between the exponents. Last example here, we have 7 sevens in the numerator. 1, 2, 3, 4, 5, 6, 7. And we have 3 sevens in the denominator. We can simplify these, and we get 7 to the 4th power. Hopefully by now you've seen a relationship between the exponents, which leads us to the shortcut. Okay, what we can do here, instead of having to write everything out, is just subtract the exponents. Okay, 4 minus 2 gives us 2. 5 minus 2 gives us 3. 7 minus 3 gives us 4. And this is basically what we have here, describing the pattern. A to the m divided by a to the n is simply written as a to the m minus n. Okay, and it's stated again here on this page. Quotient of powers property. To divide powers with the same base, subtract their exponents. 4 to the 5th divided by 4 to the 2nd gives us 4 to the 3rd power. A to the m divided by a to the m gives us a to the m minus n, where a is equal to 0. So a can't be 0. Okay, let's take a look at some more examples here. We have n to the 7th divided by n to the 4th. All we need to do is subtract the exponents, and we get n to the 3rd power. Number 2, 4.2 to the 1st power. Number 3, -8 to the 4th power. Number 4, x to the 5th power. Okay, we got a few more here. Let's take a look at the example. Simplify a to the 10th divided by a to the 6th times a to the 7th divided by a to the 4th. There's really two different ways that you could do this problem. You could either use the quotient of powers property first and then products, or products first and then quotients. I think it's easier if we do quotients first. So take these here and subtract. 10 minus 6 gives you 4. A to the 7th divided by a to the 4th gives you a to the 3rd, and then add exponents to get a to the 7th. All right. Similar over here, and what I'm going to do now is work out the denominator to get 2 to the 8th, and then I'm going to subtract the exponents and get 2 to the 7th. Over here, we're going to add a little 1 in there. Okay, remember when a number does not have an exponent, it means that the exponent is actually 0. Okay, so here we can rewrite this as d to the 4th, because I'm subtracting 5 minus 1. D to the 9 minus 8, which is 1. Okay, and that gives us d to the 5th. And for number 7, here we're going to get 5 to the 5th times 5 to the 3rd, which gives us 5 to the 8th power. Okay, I have these worked out for you. It's the same thing that we've been going through. You're subtracting the exponents, okay, for when you're dividing, adding them when you're multiplying. And sum it up. What is the rule for finding the quotient of exponential numbers? Subtract exponents of common bases. For number 2 here, you see that we have a fraction that contains multiplication. It contains 2 different letters and a number base. Remember that you can only add or subtract exponents of common bases. So a to the 3rd, we have nothing that combines with that, so we have a to the 3rd here. B to the 4th divided by b to the 2nd gives us b to the 2nd. 5 to the 4th divided by 5 to the 1st gives us 5 to the 3rd, and that's it. That's in simplest form. You can't take it any further. And the last one we have, your answer comes out to be m to the 9th, n to the 1st. I hope you found this video useful and helpful, and if you need any extra help, you know how to reach me. Have a great day, guys.